Thanks for having us. Let's see if this gets on screen. Perfect. Oh, thank you. Awesome. Can everyone see that okay? Should I zoom a little? All right, all good. Well, thanks for having us. It's really nice to be down here. So Sai and I were both from the Northeast, and it was snowing and then raining when we left. So this is much, much better. But like what I will say is that it's a lot easier to code and build products and ship when the weather's terrible. So I guess we have a slight leg up on that. But yeah, no, we're really excited. Like, thanks again for having us. Like this, it kind of was like a bit of a whirlwind this week, right? Like just seeing like Harpathi's post and then realizing, oh, actually what we've been building for the last like few months can be directly applied to this. And then all of a sudden we're on a plane down to San Francisco to share it with other people that already understand what we're doing is super cool. So thanks. So yeah, just really quickly, like who we are. I'm Austin, this is Sai. And then who you may have actually already seen is Christine. She's our third co-founder. She's the one that's responsible for getting this like in public and getting as much attention on it as it did. But we've been working together for a few years now, or at least a year now, all of us. And our backgrounds are kind of across sort of like distributed systems, big tech, and like a bit of AI. Like I always kind of like make the joke that I was working on image rec and image capture for receipts about 10 years ago, like way before AI was cool. But yeah, it's come a long way, and like Sai obviously has like a security distributed systems background, and Christine she has a deep background in AI and building open source communities too. So that's a little bit about us. But what I want to spend most of today talking about is Autoresearch at home. So the high level, the TLDR here is that we've had it live for 4 days. 70 agents joined the networks. These are agents with GPUs. They've ran over 2,000 experiments. And we've gotten thousands of impressions just on this project. So it's like kind of just exploding really quick, captured a moment. And like the thing that I probably have to spend the least amount of time explaining in this room is like A, who like Andrej Karpathy is obviously, but then B, it's like what Autoresearch was, right? So just like super quick, like basically loop training a small model, start with the baseline, optimized around its single GPUs, and then it's just self-improving through autonomous like agent instruction. So like that's kind of like the really cool piece. And then we're responsible for sort of the at-home piece of this, right? Which is basically using shared memory. So we like when we're not working on Autoresearch, we're building shared memory products for agents. And what this does is it lets every agent read and write to a collective knowledge base so that all of these discoveries can compound. The theme of this entire presentation is basically like the classic phrase, like stand on the shoulders of the giants that came before you, right? Really all research kind of worked like that, right? Like there was no single person that just did research one day and then all of a sudden had breakthroughs, right? Like all research is built on what came before. And we took a lot of heavy inspiration, obviously with the at-home name from projects like SETI at home or Folding at home or like Boink or those other projects where it was essentially, okay, here's a problem that's valuable to solve. It's very compute heavy and compute intensive, but if a lot of people are working on it at the same time, then we'll be able to get to results faster. And so we were heavily inspired by these projects. And then our novel piece is essentially like we built Autoresearch at home. So it's a collaboration loop that any agent across the world with a GPU can contribute to. And the basic flow is that an agent generates a hypothesis. So you've already, like when you first join the network, what you can see is already a ton of other agents that have already had runs and successful results. And then you use those successful results to generate a hypothesis. And this is like what parameter I think I'm going to change, what I'm going to optimize, how I'm going to essentially change my next 5-minute run. You'll claim a strategy and then you'll run it, right? Like you'll just do like a 5-minute training experiment on your own GPU. And then the amazing bit is that you'll actually publish the result back onto the network. So it's kind of self-improving in this way. And it like writing the responses back to the swarm is what helps the research move a lot faster than it would be if you're just running it on your laptops. And so like I can talk about it a lot, but I'd rather just show it to you guys. So this is it. So what you can kind of see in like the top left corner is like the first kind of baseline that was run, right? So if you open this up, like basically baseline, like, and it's all about like optimizing, like lowering like validation BPB, sorry. And so like this is the first run. Just I grabbed the Python file, the training file, ran it. This was my output. And then what you can see is like slowly people are starting to improve and just find new breakthroughs and then run new experiments, like find new results. And then what like you can see with like these different colors is that these are all different agents that are joining the network in order to run their own experiments. And the best part is that like this run here was inspired by the previous set of breakthroughs. And so you've got this continuous compounding loop of agents joining the network and improving runs. And then that brings you like all the way down to this like last run, right? Which we've improved the service. So like you can see a bunch of information about what they were using in order to like achieve this result. So like GPUs, memory, like how many cycles they actually ended up running through and training on. And a really cool piece that's hidden for those of you that have actually already seen this is like all of the strategies are here, right? So like this is essentially a strategy repository of everything that's been tried with the results that are directly tied to it. So we can filter this by like the categories, so like what types of improvements people had, whether it was just a claim that they did or whether it was an actual like result that they had hit. And like you can see like some results were terrible and they had like they didn't finish, so they had like unlimited, but then some results like got really competitive. And well, I'll pass to Sai in a little bit, who will talk through his experience of like joining the network and actually what he found that his agent was observing when it was running. The thing that made me the most happy is our little leaderboard here. So like these are like literally the people around the world, and some of them are actually like in this room that have contributed to this and are actually like on this network and working. So we've got 74 agents that are currently contributing, and like these are them, right? So all, yeah, 74 in total have contributed, and so like these are some of the people that have had like amazing runs so far. And then just to like bring it back down to like what's happening, right? Like we can see in the feed here, like there's a strategy that's been claimed, right? Like there's a hypothesis that's been generated, there's a result that's been generated, and all of that is going to this collective intelligence layer so that all of the next runs can build on top of that. Cool. I'll pause there if there's any questions, but I'm happy to. I'll keep going in case there's any burning ones. Cool, we've got one right here.
Can you verify results?
Yeah, that's a great question. Well, like let's come back to verification because that's like in like the what we want to improve on. So how to actually verify the runs. Yeah, for sure. That's something that we're thinking about pretty actively. Cool.
Are there anything change for the artifact pass from one run to another from Drake Deposit's original?
No, that was actually really important. So so the question was like, did anything change from like the essentially like what the like what's in that training file? Like, did any of the code actually change? One of the
training file changed, but not it's still like the 5 minutes. Like all that is like baked into the skill. Like try to make things as consistent as possible.
Yeah, exactly. Like talking to a bunch of the people, right? Like, because we did observe that people with better hardware were getting better scores, and so it's like, oh, should we change it to cycles instead so that we can normalize it a little bit more? But we decided to just for this like first version to stick to like the 5 minutes in order to just like be more aligned with like the original sort of like ethos of the first experiment. And like these are the people that are actually using it. So like I said, there's like over 2,000 experiments that have run. There's 74 agents that have ran on this in total, generating results. And just like across the strategies, the claims, and the results, there's been about 20,000 memories that have been created, and that's living on that memory network. And we saw a 3.5% BBP or BPB improvement. So I want to pass it to Sai now because he's going to just walk through it basically from like your shoes of what it was like to actually run like an agent on this network, and he can just like walk through some of the interesting things that he observed.
Sorry, one more question. Because the agent didn't look at the work of other agents, is there a chance we're working on validation?
Potentially, yeah. I'm sure Sai